Hello YouTube, this is code_do03 aka Harry Lunt doing another GLaDOS video. So, well, you'll hear Kean in a minute. That's McChicken. I'm just on a call with him, and I'm gonna switch to OBS to record the software bit. So yeah, no, that's cool. But for now, I'm just gonna demonstrate what GLaDOS can currently do. So. First of all, we've got the new GUI window. I will put this on OBS so you can see it. In fact, I'll just stick that on. So what we've actually got is we've got this nice button here that you can press out and press in, and as you can see, that is turning the light on and off on GLaDOS. So when it's toggled down, so it's got an impressed effect on the GUI because that's out. And it gives you a message deactivated, activated. When it's activated, you can then use this little controller, which is literally just two potentiometer based joysticks with buttons on them. And these are like what you get in a PlayStation, Xbox controller. You can literally just control, that one controls the waist, what I'd call the waist motor. That one controls the body. That one controls the neck. And that one controls the head. Now they do all work at once, so you can create some actual nice animated movements. This will go along nicely with the assistant, which will eventually, I'm not sure yet whether the Arduino Nano has enough storage on the EEPROM to hold all the movement details, or whether it's going to have to be sent through serial from the Python program, and that will just respond to it, because I haven't actually experimented with that yet. But ultimately on the program, we're going to have it so that it does an action and the actual motorized model moves accordingly, just for pure satisfaction and because this model is pretty cool. So yep, that's what I've done with the modeling. So pretty fast. It's got nice, hardly any latency on the controls. In terms of what it's running on, I think I did explain this on a previous video. Please go watch them, by the way, if you haven't already. We've got an SG90 cheap eBay servo controls the head because there's literally no resistance on it. We have, I think it was an MG90, the Metal Gear one, that was also from eBay, and it was absolutely shoddy. I don't recommend them at all, but it's still in there because it's only doing another low resistant part. We have, and I think it's an MG90D in here, which is lifting all of the weight of the front part of the body. So compared to these two, I mean, it goes a lot faster if I turn the speed up, but this is just about right for making animations and controlling it. The SG90D is a really high-end, I think it was nearly a $5 for the one motor. It's probably not an official one. It's from Banggood.com, unlike the others which are from eBay, but it's actually really good quality, and I do recommend that because it is a really good quality motor. And finally, we've just got a standard tower motor. Well, what's it called? I think it might be the Futaba S3003 I've got up here, and that's just controlling all the waist movement. So that has quite a bit more load on it. I mean, we've actually got in here a bearing, and then the pole that I've printed. I mean, this is the actual design. I've just modified slightly from an existing one on Instructables.com, but this piece up here I completely redid because the original one was like huge and a bit of a waste of space. It used gears and stuff, which generally, with my experience, gears don't always work the best. They can get jammed. So I redesigned it slightly so that it's literally suspended. So all the weight is holding off the bottom of here on a bearing, and then the motor is just turning it on the bearing. There's no gears, because gears can screw up sometimes. So yeah, new features. So yeah, we can move it, unlike the last video where it was just repeating a certain pattern. Well, that's pretty much all the model's made for, to be honest. I'm going to make the light change appropriately as well, but for now it's purely used for debugging, so I can see clearly when I'm doing stuff that isn't working, like when I've toggled it off, but when I toggle it on, it should work. So I'm going to switch to my PC now on OBS, and I'm going to show you exactly what the new program does and how it interacts through serial with the Arduino Nanos.
So, welcome back, YouTube. Now you can probably hear McChicken as well, so do you want to say hi?
Hello, YouTube.
Yeah, that's about the third time he's done that because the last two recordings didn't go so well. Um, so, as you can probably see, it is now transcribing my speech, and it'll be doing that all the time, but it isn't displaying it because you do have to say, "Hey, GLaDOS," to do that. Okay, I think it might have missed that bit. Hey, GLaDOS.
Hello again.
There we go. So now it'll display whatever I say at the top of the Takinta window here. There we go. And we now have this list of commands box, which is, it just pops out another little Takinta window. Whee! And it gives you the commands that you can do. This is pretty much all of them at the moment. There is a couple of more that are written into the program, but are still kind of in a prototyping phase. As you can see, when it said hello again, it puts it just here. And I just said the word hello, so it's probably going to pick up on that in a minute. We've still got the song buttons. I don't know whether they were in the last video. Like I said in the bit that I filmed on camera, we now have this button that can toggle the manual control on GLaDOS. For debugging purposes, it's still printing stuff here. And it is also telling you here that the manual control is deactivated or activated. And it's pressing it in or pressing it out. And you can actually see, I don't know whether the resolution picks up on it, that is an indented button when you press it. Don't know whether I had this in the last video. There's a text box, just you can submit commands in here. So, hello.
Hello, and again, welcome to the Aperture Science Computer Aided Enrichment Center.
Yep, very nice. One of the new additions that I did spend a bit of time doing. In the first song, we now have, based on the original YouTube video, well, not YouTube, the game video, we now have the symbols pop up at the appropriate time within the song, using the original ASCII text art from the game. So, there we go. Yeah. So I'll just leave that to play for a little bit, hopefully not long enough to get copyright strike. Nice. You can still either say stop through your voice or by pressing this button. Stop. Okay, maybe not. I'll have to have a look at that bit. That's a shame. That one still works. Yeah, so that's basically everything for now. So I'll just quickly go through the program and how it actually sends the commands. So literally we've got the GLaDOS, this is the main Takinta window programming down in the main loop here. This is the song section that prints the ASCII art using this form ASCII art function, which is up here somewhere. There, form ASCII art. So basically, it's just got predefined start and end lines within a text file, which is on here. Where is it? There. It literally just takes each line, reads them all in, and then copies them. That's what I did. It's not from the game. And prints them to sets them as the Takinta variable when necessary. I have now got the voice synthesis working, but I'm waiting for where'd that go? Huh. I'm waiting for a website called 15.ai to come back online with the GLaDOS voice recognition. Voice recognition? No, text to speech, because it is really accurate. a fantastic website worth checking out. But we do have now the speech synthesis working. Where is it? There. One sec, I'll just open this in File, open. So this gets imported into the main loop, the main program, just here. And basically what it does is it just uses this function here, which literally you give it any number up to 1 trillion, and using literally the numerical files, the units, the tens, the teens, and the word 100, million, billion, thousand, it can synthesize any number. So I'll just give it a run through and show you what it does.
75,476,324.
So yeah, you can hear that. It's not the original GLaDOS voice. I will have to somehow find some other audio files. This is just been text to speeched, is that a word? On just some crappy remake that's supposed to be GLaDOS. It's really not. But yeah, you can type any number in here. So just yeah, and you just run it.
43,768,329.
The 6 sounds really screwed up just because the voice generator isn't exactly the greatest. But you can see that that does what it's meant to do. What it basically does is it splits this down into 3s. As you can see here, it's added a 0 at the start, and then depending on the length, it splits it, and it then uses this calc3dig function, which is calculate the 3 digits effectively of the voice recognition, and then it will play the sound billion, thousand, million. Wait, where's the million one gone? No idea. I'll have to have a look at that. But basically that calc3dig function is within this function, and what it does is it takes the 110 unit column as a string, and it basically just converts, using the units that within there, it converts them to integers where necessary, and then plays the appropriate audio file to synthesize a number within there, within that 3-digit number. And yeah, that's basically everything for now. So I'm gonna end the video there. So see you in the next one, guys. Do you want to say bye?
Bye, YouTube.
There we go. All right, see you later, guys.